Hello everyone, welcome you in my YouTube channel. I am Dr. Mohammad Sirajul Faisi, Assistant Professor, Department of Chemistry, LS College, Muzaffarpur. Today in this video, I am going to show you one organic molecules where we will discuss about the bond length, bond angles, dihedral angles. I will show you how the CH and CO bonds is different, carbon-carbon single bond and carbon-carbon double bonds and dihedral angles. These points I will discuss today, and I will show you how you observe practically. So look at these molecules. If you see this molecule, then this molecules contains 3 benzene ring, 1, 2 and 3. If you again look, then this ring and this ring is same almost, but this is different because this blue one, you see, this blue one is, this is the ball and stick models. These two blue one is nitrogens and it is side by side, and there is a side chain, we call it side chain, this one is side chain attached with the nitrogens. So this carbon contains 2 hydrogens, so this bond must be single bonds. Now you see this carbon and this oxygen, and this carbon and this oxygen bonds. So carbon contains 2 oxygens, you know that is the acid, and now in place of hydrogens it is transferred with the CH2. You see this carbon and these 2 hydrogen, this carbon, these 3 hydrogen. So this is CH3 and this is CH2. This is CH3 and this is CH2. We call it ethyl. It is attached with the oxygen. It means before that it was hydrogen here, and it is replaced by esterification reactions and ester is formed. Now you see here this oxygens is also attached with the carbons, but nitrogen is the part of the ring, 2 nitrogens, pyridines and this carbon oxygen. Now if you look at this carbon directly attached with the benzene ring, but this carbon is not directly attached with the benzene ring. So this is very important point when you look any molecules. This carbon directly attached with the, this is like biphenyl, so directly attached with this carbon, and this carbon not directly attached with the benzene ring through the CH2. And you see this is the, if you remove this part and put hydrogen, this look like toluene. Okay, so now I will show you about the bond length. So bond distance, if you see this carbon and this oxygen, 1.192, okay, and this carbon and this oxygen 1.323. So which one is longer bond? This one is shorter and this one is longer. So you know the shorter bond, it must contain the double bond, and longer bond it must contain the single bond, and sometime conjugations, so not a complete single bond, not a complete double bonds. So in this CO, this carbon and this oxygen look like 1.192 is double bond, and this is 1.3, so it look like the single bond, not the complete single. Now look at this carbon and this oxygen, 1.2. So this one is complete double bonds. This one is also in between 1.192 to 1.32. So this one is also a double bonds. Now you see this and this nitrogen. So 1.358. This is also a double bond range. And you see carbon nitrogen's bond 1.45. So this is the single bonds. Now you see this carbon and this carbon bond 1.483, almost 1.5. You see this carbon and this carbon 1.5. You see this here is 1.48. So this is single bonds. Now you see this bond length also 1.5. Now you check the benzene ring. You see 1.37, 1.379. So you can easily identify which groups is theirs. Again I am resetting. I will show you this is same or different because this is attached with the carbon and this is attached with oxygen. So this bond must be different. You see this carbon and this nitrogen bond 1.304 and this carbon this nitrogen bond is 1.385. So which one is shorter? This is shorter, this is longer. It means here is the more double bond character than this. Now these bonds you see 1.435, here 1.4, 1.5. So this is the longer bond and this is the shorter bond. So this bond and this bond is all shorter and this bond and this bond is longer. Now check this 1.344 in between. So in benzene ring also you check this bond length. You see 1.386 and this bond length randomly 1.386. So you know the in benzene rings you see 1.369. So in the book you have read already because all benzene rings have the same bond length, but actually it is attached with the another, so there is a difference in the bond length. You see this one is 1.38, 1.83, this one is 1.394 and this one. So all bond length is not same, means it is attached somewhere else, not symmetrically. So this is about the bond length. Now I am going to calculate some angles. So look at this angles. You see this is planar, means this ring and this ring is almost in the same plane, but this ring and this moiety is not in the same plane. Why? Because this is the presence of these CH2 groups. If this CH2 group is absent and it is attached directly with here, then it is in the planes. So these two rings are in the plane, but this is not in the plane, presence of CH2. You know the methane groups is tetrahedral in nature. So this bond is almost 1, 2, 3, 116. You see? So you see this bond length 120. So friend, hope this video will be helpful to you. If you like this video, then subscribe my channel, and thanks for watching.